All right, 7.4, solving linear systems by multiplying first. Basically, this is also eliminating. This is also eliminating, but now it's not going to be as easy before where there's an obvious one to eliminate. So before, the coefficients, the numbers in front of the variable, were already opposites. So all you had to do was add the equations together and eliminate that variable. So you had 3x plus 2y equals 6 and 3x minus 5y equals, 20. So it was already the same coefficient. Or one of the variables, one of the coefficients were opposites, where it would have been positive or negative. Now, what happens if you're looking at 2x plus 4y equals 8 and 3x minus 2y equals 6? You can still eliminate these, but we've got to do a little process first. Now, a couple chapters ago, we talked about equivalent equations. 3x minus 3y equals 21. That equation has a pairing of x and y values that will make this equation true over and over again. If you take this entire equation times a number like 4, so long as you multiply everything by that number, by 12y equals, and this would be 84, the answers in this second equation have the same values as this one here. So that's why we call them equivalent equations. That will help us because looking at your two equations, your 3x minus 3y equals 21 and 8x plus 6y equals negative 14, can you see a pairing of coefficients for either the x or the y that can easily be made to match the other? Well, I have 8 and 3 here, and that's not going to be as easy to match as the negative 3y and 6y, because if I take this whole equation times 2, I'm going to use a dot, times 2, then that's going to give me 6x minus 6y equals 42. And if I compare that to my first equation, or the second equation, negative 14, sorry. Now I've got that perfect pairing of my y's, so that all I need to do is add this equation together. 14x equals, and positive 42 plus a negative 14, not thinking straight today, equals a 28. And then I can solve for my value of x as a 2. So this section, you're going to have to make an equivalent equation so that you can have matching coefficients somehow, somewhere. And the process goes the same from here. I have a value of the x. I'm going to plug that value in to any one of my equations to then solve it. So negative 3y, and I subtract 6 on both sides and get 15. That means y is negative 5. Means my ordered pair is 2, negative 5. Please, please, please take a second to check to make sure that this actually works in both of the original equations. If you take 3 times 2, 6, minus 3 times negative 5 is actually going to be plus 15, and that does work for 21. 8 times 2 would be 16, plus 6 times negative 5 would be minus 30, and 16 minus 30, yeah, that equals negative 14. Double check that this ordered pair actually is your solution. So let's show that again. My two equations, I have 3y equals negative 2x plus 17 and 3x plus 5y equals 27. Of course, nothing is going to work out very pretty unless I have my equations in standard form. So I added 2x to both sides to change the first one. 3x plus 5y equals 27. Now, taking a look at these two equations, I have coefficients of 2 and 3 for my x's. You can't see where I'm touching. I have coefficients of 2 and 3 for my x's and 3 and 5 for my y's. There's no way for me to multiply one equation to match the second one. So I'm actually going to have to multiply both equations. Now, here's the deal. It doesn't matter which one you cancel out. If you eliminate the x's, You can do that by making both of the x coefficients 6, or you can eliminate the y's by making both of the coefficients like 15. Honestly, when I do this, it really reminds me of when I'm trying to make common denominators. It's the same idea where you're trying to find the least common multiple, if you want to get some fancy math terms in there. What I'm going to do, I think I'm going to get rid of my x's. So I'm going to multiply this equation by 3 and this equation by 2. And so my first equation multiplied by 3 would be 6x plus 9y equals 51. And then my second equation would be 6x plus 10y equals 54. And now I have the same coefficients. I've got a positive 6x and a positive 6x. So to eliminate those, I need to subtract these equations. And then I get negative 1y equals negative 3. So that means y's got to be 3. So I multiplied both equations to get that. On your homework, you should show me the new equations just like before. And then we're going to take our answer for 3 and plug it back in. I would always plug it back into an original equation just to make sure. But it really doesn't matter because the value of the x is going to be the same in every one of these. Plus 17, so negative 8. And that means x equals 4. So now I have the x value and the y value. Please remember when you're writing your ordered pairs which one goes first. And let's double check to make sure this works. 9 equals negative 8 plus 17. Yep. And 12 plus 15 equals 27. Yeah. All right, so let's take a look again. I'm looking at 7x and a 10x, 2y and a 5y. I'm going to have to multiply both of these to be able to make this do something. Let's get rid of the y's here. So times 5 times 2. 35x plus 10y equals 130. And multiplying by 2, 20x minus 10y equals negative 20. And since my 10y's are opposites, I can add these equations. 55x equals 110, and that means x equals 2. And 7 times 2 plus 2y, so that's 14. Subtract 14 on both sides, and that's 12, means y equals 6. So my ordered pair, 2, 6, and let's make sure that that actually works. So 14 plus 12, yep, and times 2 would be 20 minus 30, negative 10. All right, so folks, let's take a look at what we've got here. Let's get this so it's pretty. 9x plus 5y equals negative 8. And you know what? I can multiply this equation by 2, and then my 18x plus 10y matches the y coefficient here. But I'm going to have to subtract these because they're 10y and 10y. And careful, 18 minus negative 20, 38x, and negative 16 minus negative 10. Oh, nope, I did that. Oh, but you know what I didn't do? Oh, stop and correct me. I subtracted 9x on both sides to get that. This should be a negative. And then negative 18 minus negative 20 will only actually give me 2. Yep, negative 18 plus 20, 2x, and this is going to give me negative 6. X is negative 3. Use the fact that you have the answers available to you on the on my big campus. So that's 60. Then I'd have to subtract 60 on both sides, so negative 70. Y better equal negative 7. So my ordered pair is negative 3, negative 7. And when I double check that in the original, that means that negative 35, 5 times my y, equals negative 27 minus 8. Yep. And negative 20 times x is 60 plus negative 70, and that equals negative 10. Okay, your story problems are going to be the same as before, rate or mixture problems. And then you need to make the coefficients the same so that you can add or subtract to eliminate. So Mr. Alvarado bought a total of 20 pounds of grass seed at the nursery for $168. They just told you how much or how many pounds he bought and how much he spent. He paid he paid $9 per pound for the Kentucky bluegrass and $6 per pound for the tall fescue. We're going to find the amount of pounds of the Kentucky bluegrass and the amount of pounds of the tall fescue. So we didn't get a starting fee. We do have rates, but they gave us two different totals. This is going to be a mixture. So out of these options, which one would show the possible values here? Well, we've got totals of 20 and 168 on each of them. 20 and 168 on each of them, so that doesn't cancel any of them out. But the total of 20 is the pounds of Kentucky bluegrass and the pounds of tall fescue. So I'm looking for an equation that's x plus y equals 20. And that's not C, and that's not A. So let's go to my next equation where it's $6 per pound, or I'm sorry, $9 per pound for Kentucky, and that's my x. So I'll probably have 9 per pound for my x plus 6 per pound for my y, and that should equal my 168. And 9x, 6y would be letter D. And then, of course, to be able to solve this by using elimination, I would have to multiply one of these equations by something. 9x plus 9y equals 180. 68. Subtract these, move. 3y equals, what is that, 12? 4. So that means I bought 4 pounds of the tall fescue. And if I know my pounds of fescue, or my Kentucky bluegrass plus my pounds of fescue equal 20, that means my x has got to equal 16. So I bought 16 pounds of the Kentucky bluegrass. But here is your homework for 7-4? Question mark?